In this video, we will start kinematics with equations of motion and the basic knowledge attached to it. First of all, there are two kinds of quantities. The first one is a scalar quantity, the second one is a vector quantity. A scalar quantity has magnitude only, whereas a vector quantity definitely has magnitude as well as direction. Let's take the example of a ball which is traveling with a speed of 3 meters per second. Now, if I talk about speed, speed is a scalar quantity because it only has magnitude. But if I say it's traveling with a speed of 3 meters per second along the x-axis. So now along x-axis is giving me the direction and the magnitude is 3 meters per second. Therefore, we will now call it velocity. Velocity is a vector quantity. In other words, speed in a particular direction is velocity. Now let's start off with another example. A person is standing at point A. Now this person is traveling in this direction, that is to the right, and this person travels a distance of 300 meters. The person stops here and then changes the direction along the same path, and this time the person reaches back to the starting point. That means this distance is also 300 meters. Now there are two quantities that we talk about. The first one is distance. The second one is displacement. Now distance is a scalar quantity. Displacement is a vector quantity. When we talk about distance, we will talk about the distance from O to this point. Let's call this point as A, and then A all the way back to O. So the person has traveled 300 meters in one direction and then 300 meters in the other direction. So the total distance adds up to 600 meters because we are not taking care of the plus and the minus sign. But if we talk about displacement, the person has traveled 300 meters in one direction. So let's say the rightward direction is positive. The person has traveled 300 meters in the other direction. So now we will give it a negative sign. So if along the x-axis is considered positive, along the negative x-axis, it will be considered negative. So if I add these two, I get the displacement as 0. What does it mean? Displacement means distance with respect to the starting point. In this case, the starting point is O. Since the particle, we refer to an object, a mass, a car, a vehicle, a person as a particle in mechanics. If the person or the particle is back at the starting point, the displacement is 0. So therefore, distance is a scalar quantity. Displacement is a vector quantity. Let me explain it with another example of distance. This time, the person is again at O and the person is traveling 300 meters to the right. And it stops at the point A. But this time on the return journey, the person does not reach O, the person reaches some other point which is B, and this distance is 200 meters. Now, if we talk about the total distance covered, that is 300 meters plus 200 meters, and that adds up to 500 meters. Now let's talk about displacement. What do we mean by displacement? This is distance with respect to the starting point, which is O. So now the particle is how many meters away from the origin? That is 100 meter, because this is 300, this is 200, so 100 meter is left. And how can I do the calculation? I'll say 300 is positive, and we will add to it 200 meter, which is negative displacement because it's in the opposite direction. So when I add these two up, because of the negative sign, it adds up to plus 100 meter. That is the distance with respect to the origin, which is this. So this explains the difference between vector quantity and scalar quantity. Now coming back to our topic, that is about equations of motion. So equations of motion, first of all, is only valid for constant acceleration. If the acceleration is not constant, equations of motion are not valid. So first of all, constant acceleration is a must for us to apply the equations of motion. Secondly, we need to introduce some symbols. U is the symbol for initial velocity. And then we have another velocity, which is final velocity, and we use the symbol V for it. So U stands for initial, V stands for final. The third symbol, that is T, that is the time. And then we have another symbol, A, that is for acceleration. And last but not the least, we have the symbol S. This is the symbol for displacement. Now, let's apply the units. The unit of displacement is meter. The unit of time is seconds. The unit of velocity is meter per second. The unit of acceleration is meter per second square. Now, let me emphasize one more thing about displacement. That is, if I talk about distance in one direction only, for example, a person has started from O and it has reached A, and this distance is 300 meter. Since the particle is not changing direction, so distance and displacement is exactly the same in this particular situation, because the particle is not turning around. So as long as the particle does not turn around, we can say that the distance and displacement is exactly the same. Now let's write down the equations of motion. The first equation of motion is V is equals to U plus AT. We can see four symbols over here, V, U, A and T. If three are given, we can find the fourth one. Which symbol is missing over here? Displacement is not in this particular equation. Let me write the other equation. S is equals to UT plus half AT square. So we have S, we have U, we have A, and then we see T appearing twice. Again, the rule is the same. If three terms are known, we can find the fourth one. For example, if S is known and U is known and A is known, we can solve for T and it turns out to be a quadratic equation. Now, which symbol is missing over here? The final velocity symbol is not part of this equation. Now, let me write the third and the final equation. That is V square is equals to U square plus 2AS. We have V, we have U, we have A, we have S. So which symbol is missing? The symbol T is missing, which represents time. So these are the three equations of motion that we will use in further calculation. All we have to do is to remember that these equations of motion are only valid for constant acceleration. And what happens if the acceleration is not constant. In fact, it is a variable acceleration. Then we will apply the concept of differentiation and the concept of integration. We will study this concept separately in a different video. Now let's come back to equations of motion which are valid for constant acceleration only. Let me use some words and phrases that apply to a particle. A particle is initially at a particular point. So this is the word that I'm emphasizing on, initially. When it says a particle is initially at a point, that means this is the beginning of the journey, so time t is equals to 0. When it says a particle started from rest, in other words, the initial velocity is 0. When the wording says the particle comes to instantaneous rest, it means the final velocity is 0. When it says a particle is moving with constant velocity, that means acceleration is 0. The particle is neither accelerating nor decelerating. The term constant can be used. The term steady can be used, as well as uniform is also another word that is used. In either case, it means acceleration is 0. Also, the question could say the particle comes back to starting point. If a particle comes back to the starting point, that means the displacement is 0. So in short, what we have studied in this particular video is the difference between scalar and vector quantity. We came across the idea that speed is a scalar quantity, whereas velocity is a vector quantity. Similarly, distance is another scalar quantity, whereas displacement, which is the distance measured with respect to origin, that is a vector quantity. If they both are in the same direction, distance and displacement are the same thing. And then we came across equations of motion. V is equals to u plus at, s is equals to ut plus half at square, and v square is equals to u square plus 2as. They are only valid for constant acceleration. And in the videos that are coming up, we will be using these equations of motion to solve questions for the unknown variable. So that was the gist of this particular video.